Okay, so hopefully on that last question, you recognized that this was the Aleutian Trench here, and that this Pacific Plate is pushing up in this direction here, and this is the North American Plate pushing this way, which is convergence, creating the Aleutian Trench. So let me show you a profile of what that looks like. Little thing I just draw out here. Okay, so if you notice, here's the Pacific Plate pushing in this direction. Here's the North American Plate pushing in this direction. And notice the Pacific Plate is subducting. When I wrote here, it's oceanic crust. It's slightly denser than this continental North American Plate with a density of 2.7. The reference table on page 10 indicates those densities if you look at the lithosphere on page 10 of the reference table. So I wanted to also point out this is the trench right here. This is something that scientists can actually see. They see these deep trenches and so forth. They also are able, I put little X's to indicate earthquakes. They see the trench, they see the earthquakes getting deeper as they push into the North American continent, and so they're inferring this subduction zone here. The trench, the deeper earthquakes. And by the way, I showed some melting here. Usually you get volcanic activity. All right, so that is a classic subduction zone. We'll see that not only at the Aleutian Trench, but as we pointed out, the Nazca and the South American Plate colliding together. A smaller one that produces like Mount St. Helens would be the Juan de Fuca Plate colliding with the North American Plate. Okay, and there are others all over this map here, as some of you pointed out in your write-up on earthquakes, India colliding with the Eurasian Plate, creating the Himalayan mountains. Okay, good.